Hey everyone, thank you for joining this talk today on real-time operating systems and automotive architectures. My name is Richard Elberger. I'm with Amazon Web Services. Just recently we started a new initiative within the system architecture group related to real-time operating systems and how they interoperate with Automotive Grade Linux. And this is a very new group. All of this information is just emerging. A lot of it is prone to change. This is really informational about where we are at today, how the group has started, the use cases that we're looking at, and so forth. And at the end of this talk, I will have a call to action. I'm really also sad that I couldn't make it to Tokyo this year. It's really disappointing for me, but I hope everyone is having fun there, and I should be around for the Q&A. So what we'll do is we'll see why Automotive Grade Linux should consider RTOSs. Why are they important? What use cases that they cover, and so forth. We'll look at some initial architectures. Some great work has already been done already. I just brought that up a little bit for just so people could see the lay of the land, so to speak. And then we'll go through what we're looking forward to members participating in moving forward so we can have a pretty comprehensive view about what we're doing in this space. So what is the scope of the architecture applicability with regards to RTOS? Well, everyone should know about the traditional architectures in automotive. Really, in this traditional architecture, these larger compute systems, which AGL runs on, doesn't really operate in these architectures, but it is really relevant, more applicable to domain architectures, which have been going on for a while and gaining more widespread momentum. And then what's also emerging are these zonal architectures where we have very large compute systems, a centralized compute system with an in-vehicle fabric that distributes these operations, but in a smaller sense, right? So everything is zonal, very specific, but all the heavy lifting is done within a single compute unit. All right, so when we're talking about RTOSs with regard to AGL, we're not talking about traditional architectures. We're really focused on domain and zonal architectures, okay? And so that is why I believe that Automotive Grade Linux having a story around real-time operating systems is super important, because RTOSs, as well as bare metal, but RTOSs for enhancing development practices and reusability and so forth are really, really important today, okay? But why are they important to AGL? Well, they're everywhere, like I just said. What kind of RTOSs are we talking about? Well, we're considering both open source and commercial. And as you know, with open source RTOSs, those still, it's on the implementer to go and get those certified for whatever ASIL level that they're being certified for. There's also commercial RTOSs that are pre-certified, right? And I believe that in these architectures that we're talking about with regard to RTOSs, we need to care for both categories, okay? Today, because everything is getting more connected, architectures are consolidating, we cannot treat RTOSs as islands anymore in their own ECUs, especially in these domain and zonal architectures, all right? The expectation on customers using systems today or building these systems today is that we're able to interoperate with those RTOSs better. The RTOS is actually in systems that are more consolidated. There's a deployment story, there's an update story, there's an interoperability story, and I firmly believe that Automotive Grade Linux is really well positioned to be a key player in this story, right? Because AGL can move fast, we can all move fast together, and we can bring a really great open source solution to customers who want to manage these things better. So the goal is to define these architectures on how RTOS interoperates with AGL, right? But when we started talking through this problem, as a starting point, remember, it's just a starting point, we defined 3 contexts. The first is the virtualized context, based on a lot of the great work that was done in the virtualization expert group, which is now the software-defined vehicle expert group. The next is distributed, which is this heterogeneous discrete physical systems that are interconnected, but RTOS is on a separate system, but they still need to interoperate. And then finally, the heterogeneous multi-core system, where everything is on the same compute unit, which is more lending towards the zonal architectures that I mentioned earlier. All right. What are the use cases, the high-level use cases? Well, what you'll see here is that we will be targeting things like instrument cluster, interoperating with ADAS systems, in-vehicle infotainment, and telematics or TECU systems, right? All of these interoperate with RTOSs in all 3 of the contexts that I just previously mentioned. Now, I know that Automotive Grade Linux doesn't have anything really to do with ADAS today, but still, when we're looking at an ASIL-B system running Automotive Grade Linux, it needs to interoperate because there are crossover sub-use cases there for like information sharing, propagating information to the cloud, so forth, right? So those things need to be catered to and accounted for when we're talking through how we're going to apply these RTOS use cases. So what are our key concerns for working through all these problems? Well, there are 3 key concerns that we wanted to tackle. The first is the system deployment. How do we get on the initial deployment, how do we get RTOSs integrated within these architectures? Then what we want to do is ensure that we have a really great story on how AGL communicates with RTOSs in all 3 of those contexts, right? So how does data move between those systems and so forth? And the third is, and this is pretty crucial for a couple of members, which is how do we do system updates, right? So looking back on how I feel that AGL is well positioned for this, I really strongly believe that AGL can be the centerpiece for making all 3 of these things happen. As when we're talking about domain and zonal, and also in this new way of consolidating systems using virtualization or heterogeneous multi-core. All right. So let's take a look at some of the initial architectures for RTOS. All right. And these are all 3 of these contexts were done based on the initial diagram that was done for distributed by Paul. All right. So for distributed, we actually have discrete physical systems that communicate with one another. You'll have a separate box for ADAS, as you would for Automotive Grade Linux, as you would for the MCU cluster that's doing the RTOS work, whether that's AutoSAR or FreeRTOS or Zephyr or whatever. And they're all interconnected using lower level protocols, right? So for the first 2 though, when we're looking at ADAS or AGL, it doesn't require a hypervisor in this particular case. You could use it, but if it is like a solo system, you could use it for separation of concerns, right? But if you're looking at a solo system, it could just as easily be put on bare metal. All right, but this is the initial case, and that's very pervasive today as automotive architectures evolve. What we're looking towards is this consolidation, because this is the strategy that automakers are leveraging today. And that's why the virtualization expert group is so popular, now doing software-defined vehicle. It's super popular because automakers and tier ones see the value in consolidating these systems to save costs, to save maintenance, all of these sorts of things, testability, and so forth. But we still see these two physical systems, one for the higher end application core compute and the other for the MCU cluster. And they still communicate over that lower level protocol. But in the hypervisor case, it's actually using, it would use VirtIO to communicate with the MCU cluster, right? So that's why VirtIO has been super, super important for the expert, now software-defined vehicle expert group. But moving on, what we're seeing, and has been happening for quite some time, just more from an exploratory sense, but I think that we'll really start seeing these in anger or in more widespread in the future, where we're seeing RTOSs running within a cell on the type 1 hypervisor. Okay, and so this is in a consolidated system. You could possibly consider this almost zonal, but we're still running that MCU cluster here as a set of virtualized cores. Okay, so what you'll see is that this is very similar, but using type 1 hypervisor, very similar to the next one that I will show you, which is for heterogeneous multicore, where instead of the RTOSs running on the type 1 hypervisor, the RTOSs are actually running directly on the MCU cluster, which is part of the SOC or silicon. Okay, and so in those particular cases, the firmware for these, instead of running in a virtualized cell, they're actually either being loaded on separate MCUs within. It's on the same silicon, but it's not coupled. It's not coupled with the SOC by the semiconductor manufacturer. That can be used in like an RP message way or so forth. But there's shared memory capability there. That's one way where the firmware is actually loaded or flashed directly to non-volatile memory. But in the other way, the image can actually be loaded by the Linux or the ASIL-B system secondary bootloader. Not ASIL-B, sorry. It's actually the host system secondary bootloader. Or it could be loaded using rpconfig, right, which is Linux kernel facility. But in this case, actually, the communication is very between the RTOS and the ADAS or Automotive Grade Linux systems. It's very similar to the previous slide that I just showed you. Okay, so there's some early discussions that we have had regarding data flows and how these things communicate to one another. I just really want to assert that this is very, very early, and we haven't tightened up any detail, right, on this. So this may seem like a little high level or indecisive, and that's simply because as a group, this has just started and there haven't been any decisions made. So really it's up and open for discussion. So the data flows between these distributed systems still rely on lower level protocols. But what you see here is that little green box for remote shared memory. This is a relatively new facility where you can use like remote VirtIO to access this memory and so forth. These are relatively new technologies, but really the focus on this is still low-level protocol communication to AGL, and we would actually have to interoperate directly at the SPI or GPIO or I2C level in order to understand what's coming across from the MCU cluster. But the expectation is still that using these low-level protocols, we can actually, from an AGL perspective, do things like firmware upgrade to the MCU cluster that's next to AGL. So that is a scenario that we're strongly looking at right now. The next communication is data flows is between this architecture where you have on the left-hand side the cells running on the hypervisor for ASIL-QM and ASIL-B separate from the MCUs. Again, still the low-level protocols, but actually what happens is that AGL communicates with these low-level protocols through VirtIO. All right? So it's just, again, it's kind of like a device proxy over to the MCU cluster using the host operating system. But as we move towards this all-in-one architecture, again, VirtIO plays a key role in the communication and upgrading and so forth, not upgrading in this particular case, but the communication across them. But of course, like when we look at this, what we need to be concerned with is for the upgrade, for the deployment and upgrade scenario, how do we get the cell running the RTOS situated, and how do we actually take data flows coming in from Automotive Grade Linux and outflow that somehow into like an upgraded cell. And to me, we just really need to dig deep and see what that actually means. But I think technically it's totally achievable. So this is probably the most strange one. Like heterogeneous multi-core today is still pretty fragmented across silicon manufacturers. Like many people know that I work pretty deeply with TI Silicon, and they have a really, really great, strong story about how to handle RTOS and other types of architectures using like basic Linux constructs, but it's a little bit different with some others that either use proprietary protocols or just like something that's mangled off of a standard, right? That doesn't sound so great, but what I mean is that it's like a private copy of open source that's been made, I guess, custom for the semiconductor itself. So for the most part, I believe that where we want to be is actually to use VirtIO in this case, but in other cases, like where there's fragmentation, I believe that shared memory is still the way that we need to interoperate with these RTOSs and have data flows between them. What I also found in some cases, specifically in NXP, is that upgrading the RTOS from the application core may actually not be possible. So there are some caveats here for covering some of those key concerns that I talked about earlier. All right, so call to action. I really, really want everyone's participation when the body of work that you work at, that you do day to day or you're interested in, relates to an RTOS. We really need your expert domain knowledge to ensure that we're removing ambiguities as much as possible, so we're removing biases as much as possible, and really come out with some really strong architectures that people can use and that are actionable. I personally believe that the way to first tackle that is to see what we focus on, because this is a very, very big problem to tackle. And I think that the way to achieve success is to break it down into smaller problems, and the way to break it down into smaller to make that actionable is after we do the problem breakdown, we actually do a prioritization exercise on what we action first. But the prioritization exercise, I believe, is based on the use case to the context mapping. Which contexts and which use cases matter the most? I also believe that that based on prior art, that even though my personal body of work has not really related to instrument cluster, I think that instrument cluster is probably the one that we should tackle first, because instrument cluster has been needing to use RTOS for quite some time, and their work related to RTOS has been ongoing for several years. So I think that this effort will help strengthen their story and just make it easier for customers to use IC when they're implementing that with RTOS. But with that, what we'll really need to do is pair building out these architectures with doing some concrete implementation as demonstrations that we can upstream to AGL and customers can use and tinker and ideify with. And I think that will be very helpful and very strong for users, community, and customers to, when I say customers, I mean people who use RTOS in production, use RTOS and AGL in production. And it'll just make things move along smoother. But what, even if we do focus on that, we always need to have in the back of our minds, is this like a one-way door, or are we backing ourselves into the corner for the other use cases, right? On the other hand, really, to make success, we should also play by the 80-20 rule. So that's just my own thinking on how we should be approaching this problem. But of course, as a group, totally up for discussion. And with that, thank you. I believe we have some time for Q&A, and I'm looking forward to it. And I hope that others that have been participating in this effort to date can also collaborate in the Q&A, because I haven't been doing this on my own, right? So thank you. Take care. Come on, Walt, give me a question.
Hey, Richard, this is Walt. Thanks for the talk. You look like you were in a murder room there with the red background. So we're talking to this week, Renaissance announced their new S4 starter kit. What do you think of and we're looking to acquire some, the AGL community is looking to acquire some for Yansan and Scott. So we're thinking about maybe a demo with S4 for embedded world, and maybe putting together some of these concepts. Where do you think we should focus? Kirk, Howson, and I had some initial concept talk about maybe feeding in some CAN data via multiple external boxes, kind of like your ECU concept, say Raspberry Pi based. What are your thoughts on maybe using the S4 as a demonstration mule and getting that ESP into the
S4 is great. Love RCAR. Love it a lot. That is actually the first SOC that I worked with that had an MCU on the silicon. Unfortunately, I didn't get so far to actually use it. But on that, it was like a RCAR M3. But I think was it the S3 or the S4 that we had at the AWS kiosk at the AGL booth at CES? Maybe it was the S.
Spider, right?
Yeah, perhaps.
Like S4 based. It has more inputs than the starter kit.
Oh, okay. Yeah, so sounds great. I think that actually we really need to have a few very strong choices, like just to get well-rounded. But I think that the S4 is a great system. So,
okay,
but for the effort overall, I mean, we should have a wide variety as much as possible, like J7, S32G, as well as Renaissance, of course, obviously.
I have one question.
Yes.
About architecture picture.
Yes.
Shared memory on top of that I/O layer. But my personally, I feel the shared memory layer is lower layer with bad I/O, right? Why do you put a shared memory on top of bad I/O in your architecture?
It's funny. I didn't have that. So, like this in that particular architecture, that architecture came from Paul from Harman. So I'm personally not directly involved with that specific distributed architecture. Right. Like I said in the talk, I focus on the heterogeneous multicore side of things. So I was just being inclusive to what everyone was doing in the group. But the low-level technical details of what that remote memory thing really means, I can't speak to that. And I would encourage you to join the system architecture group and speak through that with Paul from Harman.
Yeah, to reiterate what Richard just said, this is being discussed at the system architecture team on Thursday, every other Thursday, and we have
Tuesday.
Tuesday, yeah. It used to be Tuesday, and we have been having some out of band discussions as well because, like Richard said, this has been moving pretty fast recently.
Yeah. So yeah, I mean, I think that needs to be disambiguated. So we should call that out as like, if someone can, I can't do it right now or else I would, but if someone can just pop into Confluence for the system architecture team pages where we have the RTOS page on that particular architecture, ask the question, please. And then Paul can get back because I don't, he's in Germany, I think. So he's probably not on right now.
Yeah, I don't think he's on. So we have another question here, but one other thing, Richard, could you put your slides onto Sketch or email them to me, and I'll make sure they get on there?
Yeah, sure.
Okay.
Let me take care of it tomorrow.
Okay.
I'll send it to you tomorrow. Yeah.
Okay. And here we have another question in the room.
Thank you. So, thank you giving a great presentation. And I have one question for the architecture. So, in the architecture diagram, there are several H-level architecture is combined one SOC, and
Yes.
so there are SLD and B and QM. So
Yes.
is one of the SLD virtual machine, and it is communicating with RTOS, so that is SLD. So what's so how do you think AGL should treat sorry, how to say so AGL, do you think AGL should control the communicate with ACLD or more
No.
no?
Yeah. See, this is the kind of, it's a real challenging problem. So the direction of the communication only should be from D to B, and then B should only really be able to read, right? Because it can't affect the operation in any way. And usually that, in my experience anyway, I mean, I don't work in an automaker, so I might be missing something, but at least in my experience so far, what I've seen is that this segment of memory that's being written to, that's being read by the ASIL-B system, it's not something that the ASIL-B system can modify, right? And it's also not safety critical information. So it's always a lower priority than anything else that's safety critical. You see my point? So if it is something that like needs to send signal to somewhere else in the vehicle in a safety situation, that would totally take precedence over anything that would be sent to AGL.
Yes, thank you. So easily should
I mean, go ahead. Sorry.
So actually should control the flow of the summon communication, and so if it is required, then the bot IO backend side should be implemented on top of the RTOS. Sorry, so in the diagram, okay, go ahead.
Yeah, so probably right. So that is probably not the right way to display it. What I was trying to say there is that the way that AGL reads that data is through a BirdIO construct, right? So it's not that the RTOS is using BirdIO. That's not it at all. That's not what I was trying to say. So yeah, that should probably be fixed in the diagram.
Okay, thanks.
Yeah.
Any other questions in the room here?
I was trying to make the slides at least with the least amount of complication as possible.
Yeah, and he was looking at the one that is on the Confluence page, which is a little more complex than what you were showing. So,
Yeah.
anybody else have any questions here? All right, thank you, Richard. Thanks for staying up.
Yeah, sure. Enjoy Tokyo, and everyone else who actually is from Tokyo. Thank you for joining.